Welcome back again. So today we're still working sort of on addition and subtraction, but it's going to present itself a little bit differently in this video. Okay, in this video we're going to be dealing with what are called complex fractions, which has fractions being added and subtracted in the numerator and denominator of another fraction. All right, so it sounds really messy, but as long as you're very diligent, very careful, the skills from yesterday will help you get through today as well. So I kind of have a three-step process here for you. So you have to be very careful. So you want to get a single fraction in the numerator, single fraction in the denominator, and then you have to multiply by the reciprocal because obviously you're going to be dividing by two fractions. So it kind of actually encompasses all the skills we've been doing so far. So my first piece of advice would work on the numerator, okay? So in the numerator of this first one, notice I have an x and I have a y. They don't have anything in common, so to get a common denominator, I just have to flip-flop those. All right, so in terms of the numerator, what I'm going to have is a y plus x squared all over xy. Okay, so that's the numerator. In the denominator, well, this has a y in the bottom. The 1 isn't even a fraction, actually. So the 1 just needs a y over y. And then the 1 over y doesn't need anything because this is already going to create a common denominator. Okay, so we're going to have the 1 over y plus y over y, which obviously, with the common denominators, we can just write as 1 plus y over y. So that's our first step. Again, single fraction on top, single fraction on the bottom. Now let's worry about multiplying by the reciprocal. So we have y plus x squared over xy, and I'm multiplying that by the reciprocal. And again, I always do like to go like that, just to make sure we don't try to cancel things that we shouldn't. Okay? So, the one thing I notice here is this y can cancel with that y. Okay, so on top, I'm just going to have y plus x squared. On the bottom, I'm going to have x plus 1 plus y. And that's going to be my simplified answer as far as it can go. Okay, I'm not going to be able to simplify it any further than that. So again, it's not the worst thing. Okay, you just have to be very diligent about going through these three steps. All right, let's take a look at another one. So the nice thing about this one is the top actually isn't a fraction at all. So the top actually just gets to stay as x, and now we just have to concern ourselves with the bottom. Okay, on the bottom we have a denominator of x and y. They don't have anything in common, so remember all I have to do is kind of that flip-floppy process. Okay, the x needs the y and the y needs the x. So we get y plus x divided by xy. All right, so now we have to take care of multiplying by the reciprocal. So we have x. Then to multiply by the reciprocal, that would look like this. Now, to help you, if you want to call this x over 1, so as you're multiplying, you can see, oh, right, the x is on top. Feel free to do that, okay? Because on top, x times xy, well, that's going to give me an x squared y. And then a y plus x still. Obviously, that one that I put there didn't actually do anything. It was just cosmetic. So you could see that that first x was multiplying into the numerator. Okay? So let's take a look at another example. So this one, a little bit more complicated, but it is going to end up being okay. So on top, to create a common denominator, I'm going to need that x plus 3 over here. So x plus 3 over x plus 3. So on top, what that's going to give me is 2 plus 4x plus 12 over that common denominator. Or to put a little bit nicer, 4x plus 14 over that x plus 3. All right. Now, let's take a look at the bottom. The bottom has that same fraction, all right? So that 2 down there is going to need the x plus 3 over x plus 3. So that's going to be 5 minus 2x minus 6. Okay, remember, distribute that negative to both things over that x plus 3. So that's going to become negative 2x minus 1 all over the x plus 3. Then obviously this is still actually a major division problem. So again, handle the numerator and denominators separately for me, please. And now we need to multiply by the reciprocals. So we have 4x plus 14 over the x plus 3. And now let's multiply by the reciprocal. So the really neat thing here is those x plus 3's actually cancel. So all we have left is that. All right, so it's kind of cool when you simplify these, how they end up looking so much nicer, okay? But again, just the big picture. Simplify the top, simplify the bottom, then you multiply by the reciprocal and do any canceling that you can. So let's wrap this up with a word problem. So a woman drives an SUV that gets 10 miles per gallon. Her husband drives a hybrid that gets 60 miles per gallon. Every week they travel the same number of miles. They want to improve their combined miles per gallon. They have two options on how they could improve it. Option 1, they can tune the SUV to increase its mileage by 1 mile per gallon and keep the hybrid as it is. Option 2, they can buy a new hybrid that gets 80 miles per gallon and keep the SUV as it is. All right, so what this table kind of does for you is it labels out combined MPG, the combined miles per gallon, is where you add them together, right? So, option 1, the SUV gets 11 miles per gallon, hybrid gets 60 miles per gallon. Well, if X is the number of miles, well, they're driving the same number of miles, okay? So for option 1, both vehicles are going to drive X. Now, in terms of gallons, the gallons of gas is going to be the miles divided by the miles per gallon. So the SUV is now going to get X over 11. The hybrid is going to stay at X over 60. Oh, I'm sorry, I forgot to go like that. All right, so How about our second one? So still the same distance, the distance they're driving, they're each driving X miles. And then their combined gallons is going to be the miles divided by the miles per gallon. Well, the SUV is going to drive X miles and get 10 miles per gallon. But now they're getting a new hybrid that's getting 80 miles per gallon. And so now our goal is to compare these two fractions, see which one is better. All right, so let's take a look and see if we can decipher this. So here are the two scenarios that we have. All right, so obviously the top is just going to be 2x. All right, the bottoms for these have nothing in common. So that's going to need 11. This is going to need 60 in order for us to combine them. So 60x plus 11x is going to be 71x over 60 times 11 is 660. All right, so now multiplying, oh, not 21, I apologize, multiplying by the reciprocal, so the x's cancel, so we get 2 times 660, so we get 1,320 over 71, which is going to be about a combined MPG of 18.6 miles per gallon. Let's see what the other option would give. So the other option, the numerator is again just 2x. Now here, the 10 and 80 already have something in common. Okay, so this time, only this one needs to be altered, right? Because now I already have the 80. So 8x plus 1x is 9x. And then here we have 80. Multiply by the reciprocal. So the x's cancel off. So we just have 2 times 80 on top. So 160 divided by 9. That's going to give a combined miles per gallon of about 17.8 miles per gallon. So what is that telling us? Well, that's telling us option 1 is going to get them a greater combined miles per gallon. Okay, they're going to get a better deal by going with that first option. Okay, and again, I'm sure you noticed that this problem worked out to be one of these complex fraction problems that we needed to solve. All right, so again, thank you so much for joining me for this. So make sure you write that summary. Pick out something that you want to re-explain to yourself, something you want to emphasize, something you noticed, anything. Make sure you write that down for me, and then please come back ready to do your practice work.